All right, in the interest of time, so that we don't have notes end up taking like a whole hour, I'm not going to solve every single problem. I'm just going to set up a few of them, okay? First, as a recap, these letters right here, this is sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, and tangent, opposite, and adjacent. Okay? They're just abbreviations. It's easy for you to remember. So, ka, toa, right? Okay, so we already did this last time, just setting up our ratios. Sine of A, sine is opposite, so I have to go to my angle A. I have to say, oh, what's the opposite of that? Opposite is 4. What's the hypotenuse? Well, here's my 90-degree angle, so my hypotenuse, actually, to set up, just as we did last time, I'm going to go through each of these pictures, and I'm going to highlight in green my hypotenuse. I'm going to find my right angle, I'm going to go opposite my right angle, and the side that's opposite that becomes green, opposite my right angle, so that we already have our hypotenuses figured out. Okay. All right, so sine of angle A, opposite angle A is 4, and my hypotenuse is the green piece, which is 5. Sine of angle B, B is right here, opposite of angle B is 3, hypotenuse, which is green, is 5. Cosine of angle A, so when I go to cosine, this is adjacent over hypotenuse. So A, what's adjacent means what's touching it. Well, this 3 that's not the hypotenuse is touching it, and then the hypotenuse, which is 5. All right, cosine B, what's touching angle B? We've got our hypotenuse, and we've got 4. So 4 is the adjacent side, and 5 is the hypotenuse. Okay, adjacent over hypotenuse. All right, so using the inverse sine function in order to find an angle. All right, so angle F, so we say sine of angle F, sine of angle F is equal to, same as before, opposite is 10, and the hypotenuse is 23, because for sine we go opposite over hypotenuse. Okay, so sine of angle F is 10 over 23. To get just angle F instead of sine of angle F, we have to get rid of this sine from here. So to get rid of that sine from there, we're going to go ahead and say inverse sine on the other side. So angle F is equal to inverse sine of 10 over 23. Okay? So angle F, 10 over 23. We want to solve for the angle, so we're going to do the inverse sine. Okay? How does that look on our calculator? Well, this is the thing that we want to plug in, this inverse sine 10 over 23. So first thing you're going to do is you're going to go find your trig button that's next to your 7, trig button. Notice that the bottom row on the trig functions is the inverse function. So inverse sine is 10 over 23. And I check my calculator to make sure it says degree at the top, DEG. Okay? And so that is 25.77 degrees. Does it say what I'm rounding to? It does not. So since it does not specify what I'm rounding to, I'm going to go ahead and round to the nearest whole number for this notes. Okay? So 25.77, that becomes 26. So 26 degrees. So angle F is equal to 26 degrees. Okay? All right, let's go ahead and do the same thing, find angle F. So here's angle F, opposite is right here, hypotenuse is what's green, adjacent is right here, and notice that the two pieces that are filled in is my hypotenuse and my adjacent. And my hypotenuse and adjacent, where do I see those two together? I see those together with cosine. So that's why we're using inverse cosine to find angle F. So angle F is equal to inverse cosine of adjacent over hypotenuse. So 15 over 32. Okay, plug it into your calculator. Go to your trig function, inverse cosine, 15 divided by 32. 62.04, if I'm rounding to the nearest whole number, that's just a 62. So angle F is equal to 62 degrees. All right, so you might be like, hey, last time we used sine and cosine and tangent. Why are we using inverse cosine and sine and all of that stuff now? The reason why is this time we are trying to find the angle. Last time the angle was given to us. All right, so if you're finding the angle, you're using the inverse. If you're finding a side, you're using the regular function. Okay? All right. All right, let's see, what's tangent? Tangent of angle A. So tangent is, in my SOHCAHTOA statement, it's the TOA, so opposite over adjacent. So opposite my angle A is my 4, and what's touching it? This 3 is touching it, and then obviously the hypotenuse too, but hypotenuse is not part of this TOA statement, right? There's no H, it's just O and A, so 3. All right, tangent of angle B. Opposite my angle B is 3. My adjacent, what's touching angle B, is this 4. Okay. All right, let's go ahead and find angle F. So here's my angle F. Opposite angle F is this O. Here's my H. Here's my adjacent. Adjacent is touching. The two pieces that are filled in are my O and my A. So to solve for angle F, O and A, that's TOA, tangent, right? So inverse tangent of, inverse tangent of opposite over adjacent. So inverse tangent of 6 over 25 is equal to angle F. Okay? I'm not going to take the time to plug it into the calculator. We'll do that in some of the other practice. All right, moving on. So, how do we do this? Well, we use the inverse trig function to find the indicated angle. Okay? So if you're finding an angle, you're using the inverse function, the function that has a -1 at the top of it. All right, so first thing that we need to do to set all of these problems up, since it's not telling us if we need to use sine, cosine, or tangent, is we need to go ahead and find our angle, go opposite that, write the opposite, the other side's adjacent, the green side is H. Find the angle, opposite, this is the H, here's the adjacent. Angle, opposite, H, A. Find your angle, opposite, touching is A, and the green side was the H. Which angle? This time they're telling us specifically we're looking for angle B. So angle B, opposite that is this O, here's the adjacent, here's the H. All right, next figure out which two sides actually have numbers in them. Okay, notice that there's no numbers on my H, so I'm not using it. So I'm using my A and my O. Using my O and my H. Those two have numbers in them. Using this A and this H. O has nothing. Using the A and the H. O has nothing. Using the A and the H. And using the O and the A. Okay? So next, go ahead and write your SOHCAHTOA. Okay? Alright, so O and A are the two things highlighted here. O and A goes with T. So tangent. And we're solving for the angle, so we're going to do inverse tangent of O divided by A. So inverse tangent of 51 divided by 23. Alright, we're solving for the angle. So that is O and H. O and H is sine S. So, and we're finding the angle, so we're doing inverse. A and H, where do we see that together? We see that with our C, so cosine. A divided by H, so 30 over 35. Okay? So these are, whatever that is, that's what your X is equal to. This is what your Y is equal to. This is what your C is equal to. Okay? Alright. A and H. So again, so A and H, that goes with my letter C, so that's cosine. A has the 16 and my H has a 25. Again, I have an A and a H, that's my letter C, cosine. So cosine, this is whatever your X is there. Cosine of inverse 12 over 20 is equal to my lowercase a. And this time angle B is equal to A and O. Where do we see A and O together? A and O together is with this T, TOA. So inverse tangent of O divided by A. So O divided by A. So that is 4 over 7. Alright, so now from here I'm just going to pick 2 to plug into my calculator because, yeah, you already know how to just plug something in. So I'm going to go ahead and do number 5 and number 9. Alright, so number 5, I just go to my trig function, trig, and this time I'm doing inverse because I'm solving for an angle, so I got to go down to this inverse. And then 43 divided by 48. 43 divided by 48. 63.61. So 63.6, that becomes a 64. So y is equal to 64 degrees. All right, and then we said we were also going to do number 9 in the calculator. So from here, you just go, again, trig. It says tangent, so I'm going to do my inverse tangent. And 4 divided by 7. 29.7 degrees, so 30 degrees. So angle B is equal to 30 degrees. All right.